you experience innovative products like instant pounded yam flour, soy ogi, odorless fufu, kunu zaki, kasi bread, champ high nutrient density biscuit, and more? For over 6 decades, an institute has been dedicated to creating cutting-edge products, fabricating quality production machines, and milestone researches for industrial development of Nigeria. Welcome to Nigeria's foremost research institute, Federal Institute of Industrial Research, Oshodi, Fiiro. The Federal Institute of Industrial Research, Oshodi, Fiiro, is a parastatal under the Federal Ministry of Science and Technology. Fiiro was the idea of an economic mission sent to Nigeria in 1953 by the World Bank. In 1956, Federal Institute of Industrial Research Oshodi was established, and it now occupies a 5 hectares land area housing its research laboratories, engineering workshops, administrative buildings, food pilot plants, and more.
National Bank for Reconstruction, now known as the World Bank, because they saw that most of the research that was done in the country were diffused without any clear demarcation. So that was actually what actually brought about the formation of this great institute, so that all the research that was being done will have a direction.
I've known about Fiiro from the time I was in school. I've even come to use the library here for my research work. So Fiiro has always been sort of hot-edging research, also meeting the needs of our nation.
Our research here is carried out to empower industrialization, to encourage small and medium-scale industries by transferring our research output to them, to make them industrialists.
With this enormous facility, one will wonder what the cause of this great institute will be.
To the nation.
These landmark achievements' execution rests on the well-structured department of Fiiro.
we have a mandate of providing the prototype equipment and plant to complement the developed technologies from the laboratories. That's what we do, and by providing that, we are able to translate the research results from the laboratory into what an investor or entrepreneur can take up. We have some divisions, like we have project and process development division. We have PEDS, that's prototype equipment design specification division. Then we have application technology, we have material and methodology division, and we have works and services. We have material labs, we have ceramic labs, we have electroplating. So those ones, they have lab. But in fabrication technology, we have workshops, which is another way of creating laboratory. And those workshops are where we do our work, like machine shop, where we do drilling, doing surface cleaning, and then lathe machines to make some parts and so on.
Welcome to Prototype Design Specification Division. This is a division under Project Development and Design Department. The division has some specific objectives with respect to technology transfer, training, consultations, which we offer to entrepreneurs, SMEs, industries that are involved in food and agricultural processing equipment, manufacturers, automobile, the health sectors, with respect to biomedical engineering, amongst others. We also help to create new generation of engineers that have professional experience in CAD and industrial automation. These engineers are able to design and implement and maintain sophisticated IT systems by themselves to improve and modernize the industrial activities. We also provide computer analysis and simulation, such as finite element analysis, which you can use in car production. We also offer rapid prototyping systems to produce new products and redesign defective products through reverse engineering.
Welcome to Automation and Engineering Academy. It's an automation center. Like we know, automation has to do with using the use of technology to solve human problem, whereby you bring less of human intervention. So we provide technological services. And one of our technological service is system integration. We also provide industrial automation. We provide building management system. We also provide instrumentation and control for industries.
These are pneumatic training station. As you can see here, we have pneumatic cylinders and valves, and we have the solenoid controlling the valves. Here, this is where this station gives trainees or technicians understanding of how pneumatic cylinders works, where you have the forward stroke, the backward stroke, and the forward stroke from the help of the valves here. With the help of the pneumatic, the solenoid coil, we could control this station from the PLC, telling the cylinder when to go give a forward stroke or a backward stroke.
This is Automation and Engineering Training Center. This is one of our training rooms that holds the capacity of 40 students. So in this training room, we teach students or we teach trainees on various aspects of automation. One of our major equipment in this room is the PLC, which is the Programmable Logic Controller. So we have our training rig by this side, where we have different training rigs where students can train with. Also on that table there, over there, we also have our printed circuit board machine where students can also print on the circuit board, whereby they will put electronics on the board and make whatever project they want to make. And right over here, we have our electronic board, whereby we use to train students. And on this table, we have different devices. Like you can see, we have the Siemens ET200 extension module. Like on this panel, we have the HMI, which is also called the Human Machine Interface. Like in the industry, if I want to operate any machine, I don't have to go to the panel when it comes to automation for me to operate my machine. All I just need to do is to integrate them into a platform called the Human Machine Interface, which you can see is a screen where we operate all the machines. So all the machines in an industry can be integrated to one screen and they can be operated from that screen. Like you can see a motor and you can see a graphic design on the screen. So from that screen, I can turn on the motor. So from that screen also, I can turn whatever device I need to turn. All I just need to do is to integrate. So these are things we teach students in this training center in order to provide flexible and competent solution to the outside world when it comes to technology and when it comes to the aspect of automation.
In this place, we are in pattern workshop in foundry and metallurgy. What we do in pattern workshop is just to get a pattern of a product. In foundry and metallurgy, we do casting of material component, machine component in this place. So but before we started, we need a pattern to do our work. Before we get the pattern, we need a design, a 2D or 3D design from the client or from the customer. When we get the design, then we now come to our pattern workshop in this place. We do the patterning for them. We make use of wood pattern in this place. We have different equipment here to do the patterning work. We have radial arm saw, lathe milling machine, and a bandage saw, and other cutting equipment in this place. When we get from the client, we get what they really need. We now use all our equipment to cut based on the product we want to produce to make the product out. So the product, the pattern now will be exactly of what we want to get out. It will be like the product we want to produce. So when we get the pattern, for example, this is a part of a pattern we have made in this place. This is a pattern. This pattern is for brake disc in a vehicle. It's a brake disc vehicle. You know, also with it is also a core. It has a brake disc core. The pattern also has a brake disc core. The core is just if there is a hollow. When there is a hollow in the product, it will serve to block the flow of liquid metal to that place. So when we get the pattern, we now go to our foundry floor. We make a mold. We make use of green sand mold technology in this place. That means the sand will be moist a little bit. We add water to the silica sand and some other material like bentonite as a binder. Then we now make the mold. We use the pattern we make in this workshop. We place it inside the sand. We now ram it. By the time you remove the pattern, you get exactly the product. You now form a sand mold. So the sand mold is what we are going to use to produce the product. And after that, then we now melt. We have a melting section in our place, in this place, where we make use of a melting. We have a preheat furnace, a furnace that we put crucible inside. Then we now melt at high temperature. We put our scrap material inside the crucible pot. We now put the pot inside the melting furnace. We melt. For example, if you are producing non-ferrous material, like maybe like aluminum or zinc or copper, we melt using the furnace. Even we can handle up to cast iron as high as 1,400 degrees centigrade. When we melt, the solid scrap now turns to a liquid metal. The liquid metal will now be poured into a mold we already make using our pattern. When we pour the mold, after that, if we solidify, after solidifying, we can remove the product from the sand mold and do filtering operation to clean the part they produce iron, the product. We now make it smooth. After that, before we go for machining. So that's all what we do here in producing the products.
Here is a machine shop, workshop, where we have the milling machine, lathe machine, CNC software grinding machine, and universal grinding machine, both internal and external. The other small one, we have a tool and cutter grinder there also, and one horizontal milling machine. Here in the where we are now, on this milling machine, this is universal milling machine, where you can use it for both vertical and horizontal. So on that, we can do what we call gear that we can use to assemble our equipment. After the bench working, then we do an equipment for the research processing. This is a lathe machine. A lathe machine is being used for boring, turning, threading, for facing and step boring. For a lathe machine, you can use a lathe machine to do a precision work like a mold work that you can use it to do threading, use it to do facing. This is a cylindrical grinding machine that you can use after turning from a lathe machine and you have a way of like you want to harden the material. After hardening it, you need to grind it to a bearing seat. You can grind both internal and external for a mirror finishing. It's a horizontal milling machine. Like I told you earlier, I said we can use a milling machine to mill gears. And for example, if you look at my hand, I have one in my hand. This is a bevel gear. We can use this machine to mill this gear out and to shape it to the way it is now, so that after you can now even use it and to compare with the imported one. So we can use this machine to cut different type of gear. If you look at this place, you have this is what we call dividing head. It was the dividing head that we need to even use to clamp the gear. When we clamp the gear, we now start the machine to start even indexing our place to the number of the calculation of the teeth we are going to cut to get a result of the type of gear we want to cut. This is a CNC hydraulic surface grinding machine, and this hydraulic surface grinding machine is being meant to grind a 90-degree surface for a good finishing. And what I mean is that when you have a surface of a plate that you've already even machined or you milled, definitely you have a two impression on top of the material. But when you now bring it to the surface table, which is magnetic table here, you place it there and you lock it up. You program whatever you want to reduce from there on this PLC surface screen. You program it, then you now lock it. You command it to start the work. After starting the work, you now grind it to the exact what you want it to take out of the material and to give you a good finishing. And at the same time, if you have a small piece of a metal that you want to put them in a 90-degree surface in a good finishing, then you can put them in numbers there, and you will grind them at the same time. Either is in 20 or and above, you will grind them. Once the table can even can easily be able to accommodate the number of the plates you want to grind, it will grind them once.
This department, it comprises of 5 divisions, namely the production, the analytical research, analytical marketing, food safety and quality management /HSC, and laboratory management. In the production division, this division actually all the finished research are now taken to the pilot plant for people to come for training workshops on learning some of these our technologies, and also for production of some of the items that we do sell. And I'd like to just list a few of them. We have the fufu, the instant fufu. The fufu has been dried and it is odorless. We have the infant soyogi and we have the adult soyogi. And you know it's a winning food, the yogi, for the children. But it's just like water and carbohydrate, no nutrients inside of it. So the soyogi we have been able to make here in Fiiro. It has vitamins and it also has protein, which is brought into it by using soy ugi. Then we also have the instant pounded yam. we have the plantain flour too, which a lot of people have come here for training on how to make the likes of Ola. They got the technology from here in Fiiro. And then we have our prime bread, the Kasi bread, and that has about 20% cassava flour incorporated into wheat flour. And that has there's been a lot of controversy over it, but then we have carried out some research on it, and we have even found out, a lot of people will say, oh, why cassava inside of bread? That means those who are diabetic, we are increasing the carbohydrate level, that it's going to be converted to sugars and things like that. But we have found out, we've done an extensive research on that, and we found out that it is the GI, glycemic index, is even lower than if you use whole wheat. So those are some of the, and then we have this one, the palm wine, which we have been able to bottle and preserve the palm wine. So anytime, anywhere, you can drink palm wine.
You are welcome to our central laboratory. This lab is ISO certified lab. And I mean ISO, I mean International Organization of Standards. That is, any work done in this lab, if you take it to any other laboratory, it will conform to standards. I will be taking you through the equipment we have in this laboratory, the instruments we have here. I'm starting with high performance liquid chromatography. This instrument is used to analyze some sample. Maybe you have an analyte or some component in your product that you have already made claim that is of this quantity. We use it to check whether it conforms. For example, I have a product in my hand in which they make the claim that it contains some components like vitamins, and the quantity has been stated. So what we do in the laboratory is to bring it to analyze using these instruments to check whether it's actually there. This is another equipment, GCMS, meaning gas chromatography mass spectrophotometer. We use this instrument also for analysis like organic substance in a sample. This is what we call molecule. It's our water system. This system gives us type 1 and type 2 water. The type 1 is distilled water, while the type 2 is deionized water. It's already processed because in the system it has a water bed in which it has processed the water directly from our reservoir to what is required of the lab. We have distilled water for some analysis that require distilled water, and we have deionized water majorly for the work of HPLC because we use deionized water in our process. That is why I said that it's a control lab. Whatever we do here, it is of high quality. The name of this instrument is Atomic Absorption Spectrophotometer. We call it AAS. It is used to analyze elements, that is for elemental analysis. That is for environmental evaluation. If you take any sample from the environment, you want to see the impact of the pollution that has come into that environment. We use this instrument to do elemental analysis. Maybe, for example, you have wastewater that has been discharged from company into the environment. You want to see the load of chemicals in that water. When I mean load of chemicals like lead, if the water contains lead before it's being discharged, we analyze the sample here with atomic absorption spectrophotometer to see the contents of the lead in the sample. Because every element has its own permissible limit in the environment. If it exceeds the permissible limit, that means it is dangerous to be discharged into the environment. So most of this elemental analysis we are doing here, and apart from environmental evaluation, we use it to do essential elements in food, because there are some elements that are required into the system, into our body, in our food. For example, we talk of sodium, magnesium, all these elements, calcium, they are very essential. We call it them essential elements. So all these elements, we analyze them in our food sample to see whether they are there and at what quantity are they there.
I am the head of this food through cassava processing pilot plant, Fiiro, where we upgrade all the research work from the laboratory to finished products. We deal with all the roots, the cassava roots, whereby we process and produce mechanized gari, mechanized fufu flour, high quality cassava starch, industrial cassava starch. We also go into cassava chips, and then also deal with cereal, which we call soy for infant and adults. Also, we process and bottle natural palm wine, preserve natural palm wine here for consumption here and for exports. This is a dry milling machine with cyclone. The product is dropped direct inside it, and then as it's milling, it's coming out from there. The cyclone is just to prevent dust from mixing with the products that is being milled. I say we use it to mill soya bean after drying, millet, and the corn. This machine is called the huller. We use it to dehull grains like soya beans to break the seeds into two. Then before we go and then aspirate it. This equipment is the gari automated equipment brought from England and stored here for the processing of mechanized gari. So from the granulator there, the gari falls down to the conveyor belt, which takes it to the generatorization. The generator here that generates the gari products, the granules, then which enters into the rotary dryer for drying. As the drying is coming out from the other point there, where we collect the dried products, we have a vibrating mesh there of 3 different sizes. The first size collect the main the cocoa, the second size is the main gari, then the last one down is gari flour. That's how it operates. After the remaining one on the top, the first press, you have to remove it to gari. This machine we call it screw press. That's manual press. We use it also as a dewatering machine to remove water from any product we are producing or processing, like cassava starch, cassava mechanized gari, cassava flour, and the cassava industrial cassava starch, and high quality cassava flour. This when we are dealing with small product from quantity of 2-3 bags, this is what we use because you can see it's manually operated. The name of this machine is hydraulic press. It's automatic. We use to water in our products, whether cassava flour, cassava starch, industrial, high quality cassava flour, or mechanized gari, whatever. We use it for commercial purpose. We can load up to 20 or 30 bags at once. And within a couple of minutes, that one forms a cake, the water is off. Then we drop it and we load another one. This very machine is called the detoxifier. We use it when we are producing high quality cassava flour to remove the cyanide, which is poisonous substance in cassava. Why? Because when we are producing high quality cassava flour, we have to start the process that day and complete it that day. So we have to, after wet milling the tubers of the cassava tubers, we pour it into this is about 200 liters capacity. We pour it into this place to remove the cyanide at interval of 15 minutes. Has to be here for complete 2 hours. So be sure the cyanide is removed. This machine, we call it wet thermal milling machine for milling our wet products like mechanized gari, ogi, soy ogi. We mill the corn here too. So this is the work for this milling machine. It's wet milling machine. As we are milling, pouring the product through there, we pour in water, collect the the slurry from this point. And then we take it, if it is a high quality cassava flour, immediately we collect, we pour into the detoxifier to remove the cyanide. If it's cassava, industrial cassava starch, we remove it from it, collect it, go to the vibro sieve machine where we separate the fiber from the slurry. This is our pulper. We use it for mechanized fufu flour, mechanized fufu. After we have gotten our cassava tubers and peel it and soak it for 4 days to ferment, then we'll carry it here as they do it locally in the village. They use hand to do it. We start putting it here. This machine will separate the fiber and the slurry. We collect the slurry and remove the slurry and put it back inside drums to sediment for 24 hours. Then we remove the water, collect the slurry for the watering, and then granulating and the drying. It's our stoked granulator, where all the products are come out from our dewatering machine, either from a screw press or from the hydraulic press. The cakes they form where we break it into granules for easy frying and easy drying. The moment you close it like this, then we have started operation. We start feeding all those products, whether it's mechanized gari or mechanized flour or cassava starch or industrial or high quality cassava flour. We must pass through this very granulator. There's a big drum here with a basin that collects the thing that granulates to very small particles, or to less than 200 microns. This machine is called cone blender. This is when we want to add premix and flavor to our soy product when we are processing soy products or producing soy products. We also use when we are processing mechanized gari flour. When we want to produce groundnut gari, powder gari, and coconut gari, we have to use this blender to blend them together. We want to add ginger to our ogi, either ogi baba or ordinary white ogi. This blender is what we use to do that. Feed it then and bread them. We have a count of 15 minutes. Then it's blended. Then we remove it and pour another one. This machine is called vibro sieve machine. We use it when we are producing industrial starch or edible starch to separate the fiber from the starch slurry. So as we are feeding the slurry from after wet milling from the other side, as we are feeding here, this machine vibrates and we are pouring water. There's a basin here, we collect the slurry and then pour it to different drums that are lined up here. If it's automation, there's be a conveyor that conveys to where you pour it. When you collect them separate finish, then we remove that one and pour another one until we finish the volume of industrial starch we want to process. This machine is one of the most modern drying equipment. We call it fresh dryer. Here we use this machine, one of the latest machines we have here, used to dry all the product that comes out in powder form. It can be automated, it can be used manual as I'm holding this to feed the fresh dryer. And we are feeding it, we use to dry mainly our high quality cassava flour, industrial cassava starch, mechanized fufu flour. We don't use for gari. We use also dry soy and plain oat into powder. That's the method to do. Whatever product dry here comes out in powder form and is going for packaging. Here is our palm wine processing section. When we collect the palm wine sap, the sap from palm wine tree from the farmers at our different locations where we get them, where we have farmers. Then we store them on these drums, these blue drums, for fermentation for about 12 to 24 hours. But before that, when we collect our bottles, inside brand new bottle or used bottle, we soak them on these metal drums, metal drums, and that washing basin. We soak them there for at least 24 hours before they start washing the bottles. When the bottle is ready, then we go for our palm tree sap.
We collect the volume we want to collect, maybe 200 liters, 500 liters, depends on the volume we want to produce, the batches we want to produce. Then we store them on these blue drums. From there, we start processing it. When the processor and blending, add all the premix, like the preservative, that's only we add the preservative, then mix it, get it ready, then we take it to our mixer. After we have now fermented the sap from palm tree we brought from that place, then we put into here to mix it. After mixing for some 1 hour or 2 hours, then we start feeding it from this point. Start feeding it from filling the bottles here. Because we are not yet automated. We start filling the bottles one by one through this nozzle. There's the other nozzle the other side. We fill it there. As we are filling the bottle, this mixer will turn it. We on this thing, it will turn. So we'll be turning the thing so that we will not have some thing left behind that is big. So to blend it well, that's the essence of this mixing machine or homogenizer. We call it mixing machine or homogenizer. From the mixer, after filling the bottle, they will bring it to this our working table. Fill this place with bottle. They will start corking it. As we put the crown cork on the bottle, we cork it this way. As we're corking it, we're shifting it to the other side, right side, where we put what we call anti-rust oil. As we put anti-rust oil, the next place we are taking it, then we move to the pasteurizer, where we pasteurize it for at least 1 hour, 30 minutes. As we are cooking at our working table, then soaking the crown cup with the anti-rust oil, then we are loading into the pasteurizer. We have 2 pasteurizers we have here that we can load up to 1,200 bottles at a go. And when we load finish, we use this pasteurizer, is a standard pasteurizer. It uses both electricity and gas. That's why we have this control panel here that controls it, control the heat.
This is Chemical Technology Division of Chemical Fiber and Environmental Technology Department of Federal Institute of Industrial Research, Oshodi. Our area of research are in 4 areas. Number 1 is the utilization of oil seeds for production of various products. That is, we extract oil from large number of Nigerian underutilized oil seeds. So we are looking at some of the large number of the oil seeds that are available in Nigeria, other than the main raw material for soap production is PKO, that palm kernel oil. And we have a large number of oil materials that can replace this PKO, and actually either in blend form or in pure form that can bring the cost of such production down. The second one is extraction of colorants, natural colorants from natural materials. We have a lot of our food materials being colored, and most of the colorants we use currently are synthetic and sometimes toxic. Another area of our research is in soap production. Long ago, people are producing soap, and some of our soap production are commercial soap production that are foreign based. So with economic downturn, so we need to actually explore our own resources. So what we are also doing is that soap production is not new, but we have a lot of materials that can be used for soap production to reduce cost. And Fiiro, as an institute, is actually training a lot of SMEs, that is small, medium scale entrepreneurs, in soap production. And every week And every now and then we have a large number of people coming here for training on soap. Both the bath soap, the laundry soap, the black soap. The other area of research is cosmetic. In cosmetic production, we have a lot of, we still use the same raw materials that are widely available in Nigeria for cream, lotion production. In local areas, they do some of these. So what we are also doing is that some of the oils that are being used has a lot of these potentials. So what we are just basically doing is that we are looking at the resources available in our local area and some of the daily products that are used in every household.
We do research and development activities into industrial wastewater from various industries, and we have treated effluents from paint industry, pulp and paper, textiles, tannery, food and beverage, plastic industries. And we all know that industrial wastewaters are discharged indiscriminately into the environment, which has a hazardous effect on human health. It affects the aquatic ecosystem and also degrades underground and surface water. So what we did was that the research started from the lab. We collected the raw effluents from the industries that I've mentioned, and we took them to the laboratory to determine the pollutant levels. The effluents were analyzed chemically and microbiologically. We analyzed the effluents, and after also the treatment materials, we also did some research into all those. And after we had completed the research work and we had effectively treated the effluents, that was when we transferred all our results to a product design and development department. And they are the ones that designed and fabricated this equipment. It's a universal pollution abatement. Universal pollution abatement in the sense that it can treat many effluents, whether it is from the paint industry, the tanning industry, the textile industry. It can handle all those effluents, and they were fabricated from locally sourced materials. And even our research in the laboratory started from using locally sourced materials. Now we get our effluents and we put it in the utilization tank. Then you can see that it's powered by an electric motor attached to a steerer. So if the industrial wastewater happens to be acidic, then we neutralize it. In this equalization tank, neutralization takes place. So if it is an acidic industrial wastewater, we make it alkaline to neutralize it by adding an acid solution. Effluent is steered. Then inside this equalization tank also, we add the coagulants. We allow it to steer very well. So it's now pumped into the sedimentation tank. Coagulation takes place. We have the supernatant liquid on top, and we have the sludge below. Also, like I said, from our studies in the laboratory, we also know how long it's going to stay in the sedimentation tank. Then the next thing we do is that we remove the sludge leaving the supernatant liquids in the sedimentation tank, and this is the intermediate treatment stage. For the intermediate treatment stage for the treatment of our effluents. From there, we now pump the supernatant liquid into the adsorption tank. In the adsorption tank, it goes up like that into the adsorption tank. In the adsorption tank, we have some adsorbents. This is the tertiary treatment stage. So by the time we're discharging what is in the adsorption tank, we are discharging our treated effluents. It's either it could be safely discharged into the environment. It could be used for agricultural purposes. Like this, the raw effluent from the pharmaceutical industry, and this from the paint industry. This from the pulp and paper industry, the raw effluents. So by the time they are treated, this is what they're going to look like. And you can see that they could be used for agricultural purposes, they could be safely disposed into the environment, used on agricultural land because it's good for the soil. Also, we were able to produce dense hollow blocks, and we have been able to utilize it to produce rice husk. And these blocks, we can use it in buildings. And also from the rice husk, we can also research has been done in the laboratory, and we've been able to produce sodium silicate. Also from the rice husk, this rice husk that I showed you. And this is used in the soap industry. We have slaked lime from carbide sludge. And carbide sludge is produced when you mix calcium carbide with water. It's a byproduct. Then you get you produce the acetylene gas that the welders use. This last one is cashew nut shell liquid. This cashew shell nut, we all know what cashew nut shell, the cashew nut shell. Normally, after removing the cashew nut, we will normally throw it away. But we now have the shell, and from the shell, we have been able to extract a liquid from it. And some research work was done on that liquid in the laboratory, and we now got this cashew nut shell liquid, and you can use it to paint wood to prevent termites from destroying the wood.
You are welcome to our division, Pulp and Paper Technology Division, one of the divisions in Chemical, Fiber and Environmental Technology, Federal Institute of Industrial Research, Oshodi. Primarily, our assignment here in Pulp and Paper Technology is to carry out researches on how to source long fiber from various plants, agro waste, and other annual plants available in this part of the world, Africa and then Nigeria to be precise. Pulp and paper, as we all know, that's the technology whereby we get our paper and paper products. And paper, as we know, is one of the universal materials that from cradle to grave, it plays vital role. From inception, lots and lots of work has been carried out to source this long fiber. It may interest you to know that majorly the materials we have in terms of plants or trees we have around, they are mainly of short fiber. Not that you won't use short fiber to produce pulp and paper products, but the point is that if you need good quality pepper, you have to zero into long fiber material. Somewhere there, we have something that resembles okra stem. That particular plant, generally it is known as kenaf. It is a good source of material for long fiber. And long fiber material in temperate zones like Europe and elsewhere. If you want long fiber material, trees like pine, spruce, and other plants will give you that. Here in the tropics, of which Nigeria belongs, we have just very few materials that can give you that long fiber, but we don't have it in large quantity. But for you to produce your pulp and pepper products, you need larger percentage of long fiber material. So if you want to work using tree or plant as we know, you go to the forest, you get your wood, you bring it down here to the lab, then you do the elementary processes. You debark the wood, cut it into rings. Essence is for you to have easier way to do what we call chipping. In integrated pepper mill, you may have what they call chipper that will help you to chip those woods into smaller sizes. You need to reduce it to those sizes so that as you carry out the pulping process, the chemical you are using will have larger surface area to react with the wood. All in an attempt to remove lignin. Lignin is one of the components that make up lignocellulose material. Wood or plant, as we generally know, is made up of three major components. You talk of cellulose, you talk of hemicellulose, you talk of lignin. Outside other things we call extractives. But for a pepper maker, you are concerned mainly with the cellulose, and that's what we call the fiber. Cellulose, chemically, is a polymer. So, for you now to get it as an individual entity, which is the fiber you are looking for, you have to carry out the pulping process. There are various methods you can carry out your pulping. There is mechanical approach. In mechanical approach, you don't need chemical. So the equipment or machine they use is the groundwood machine. Now that one has advantage and also lots of advantages. And for the fact that technology is progressing, it's better for one to look for easier, lesser cost, and other maybe something that is more environmental friendly. So in that wise, you also talk of chemical pulping process. Chemical pulping just entails that you engage chemical in a particular equipment we call wood digester. So you get your material, you have done your chipping, that is reducing it to smaller sizes, take the weight of the portion of what you want to work on. So you just put it inside the material, inside the equipment, prepare your chemical. In preparation of the chemical, we call it preparation of cooking liquor. Which chemical do we normally use? You can use if we are talking of soda process, that one you are using single chemical, which is our conventional caustic soda or sodium hydroxide. But if you are now dealing with wood material that need aggressive chemical to attack the lignin, you now use what we call sulfate or craft process. So in that one, apart from the caustic soda or sodium hydroxide, you now add another chemical we call hydrogen sulfide. There's a ratio. You may use 2:1 ratio to do whatever you want to do depending on the quantity of material you are dealing with. So if you now get your chemical, you've gotten your material, you have known the volume of water you will use to prepare your cooking liquor. That one is also very necessary, because if you use lesser volume, the concentration may not give you what you want. If you use lesser, there may also be problem there. So there's a way we normally do it. By the time you must have determined the moisture content of the material, that will now give you a clue on how to know the volume of the water you will use to prepare your cooking liquor. So when you have gotten all these things, you just charge everything into the digester, then cook the digester, tight it very firmly, because it's a machine or equipment that works under high temperature and pressure. Those two parameters are very necessary. So under high temperature and pressure, in the presence of chemical, then that's when it will now have the ability to delignify the lignin and remove it. In other words, what you have achieved is to separate the lignin from the cellulose. So the cellulose will now be free. Once you get that, now that cellulose, or what we call fiber, is the pulp. So if you get to this stage of obtaining your pulp, this is now the basic material you need to produce. If you want pepper, depending on the type of the pepper, if you want the one we use as stationery, for printing, for writing, there are other processes you will do. But if you need what we call craft pepper, maybe for packaging, it's brownish, then you add some additives and make it thick enough to contain whatever you want to do. So if that is what you want, or maybe you don't want pepper products or pepper materials, but you need other pepper products like sealing board, cardboard, and other things, this same pulp, you can now use it to do all those ones. So you bleach it. By so doing, you have now dealt with the remaining lignin inside that pulp. After bleaching, another stage you need to do is what we call beating process. During that beating process, a lot of sizing process has been carried out depending on the quality of the pepper you desire. So additives, you can things in the class of calcium carbonate, kaolin, and all what's not, you make them available and add them. So once you finish that one, pass it through the sheet former, you now get your pepper sheet, you do your calendaring, that is smoothing it, then you now cut it to the size you want. If it's what we call the conventional A4 size, you cut it. If the one that will give you normal exercise book, you do all those things and package it the way you want it.
Polymer generally is just you can say it's a macro molecule, and polymer is divided into two types. We have biopolymer or natural polymer, and we have synthetic polymer. Now, biopolymers are proteins, nucleic acid, DNA, cellulose, starch, a lot of things that are of plant base that are polymers are called biopolymer or natural polymer. So before now, let me talk about material evolution. We have what is called, we are in polymer age generally in the entire world. Before now, we have what is called Stone Age, and then we have Iron Age. And then I can say authoritatively that we are in polymer age, where virtually everything that is almost 80% of what is being used in this world is made of polymer. In polymer and textile, I have about 5 laboratories, but it's basically divided into 2 sections, polymer and textile sections. Natural polymers, we have been able to process fibers and develop a lot of products from the fibers. For instance, I've worked on plant fibers like kernel, plantain, banana, and some other fibers. What we do basically here is that we use those fibers for production of products like bags, shopping bags, agro-sack bags, and other useful products. This is one of the labs that we do research and development. And like I said before, that it's divided into polymer and textile sections. I want to show you some of the products that we have from our research. We have, you remember I talked about kernel, plants, banana and plantain that we use for shopping bags and agro-sack. So this is what I mean. This is a sample of the fiber from the kernel, and this is the spawn fiber. Now what we do is that you get the plant, you extract the fiber, and then you spin it into a spawn yarn. After that, now you use this yarn to do what is to weave it into bags.
We are right here in the Packaging Technology Division's lab, or Packaging Technology Laboratory. In our laboratory here, this is where we carry out various tests for all our food samples that comes in, and the packaging material to be used as well. After necessary scientific tests must have been done on the packaging material to be used. And like you can see with our cream of scientists working on the bench, right here now, you can see our desiccator where we used to cool some of those samples that goes out for eating. You see our pH meter there for the measurement of pH. After that, we see our chemical balance. We most of the samples we need. And behind me too, you can see a vacuum sealing machine and other packaging materials which are necessary to be. We also have some laminates here too. These laminates are equally part of the packaging materials that is used for the packaging of different food substances. So the normal routine is just that when we have our samples, if it comes in like that, the necessary test will be carried on. In this laboratory too, we do what we call graphics and design. Graphics and design is an integral part of packaging, which we in here too, such that you have the required market appeal of any product. If the required designs are not done by way of making sure we use the required graphics for the final packaging material which we've developed, this may not meet customer appeal at times, but this graphics is also part of what we do in here. We come up with graphics of various forms for different levels of users. The more important things going out, which we do in this lab too, is securing of barcodes to any of these materials we do at the end of the day in conjunction with the Manufacturers Association of Nigeria. But over here too, these are some of the things we do, because if you want your products to get out to different malls out there, packaging may be secondary, maybe primary, but an integral part of packaging, which is barcoding too, needs to be embedded, which we also help out our clients to achieve.
Department of Biotechnology is one of the technical departments in the institute. This department is set out to use industrial biotechnology to produce goods and services for mankind. Currently, we have 3 divisions in the department. The 3 divisions are the Enzyme Technology Division, and And we also have the waste utilization and fermentation division. And then we have the molecular biology and genetics division.
This is the molecular biology laboratory, domiciled in the biotechnology department of this great institute. And what we do here is to analyze 3 major biological molecules: DNA, that's the deoxyribonucleic acid, RNA, ribonucleic acid, and proteins. I would say this is probably one of the institutes in Nigeria that can boast of having this kind of standard molecular biology laboratory. So first of all, that stands us out of every other institute. And then secondly, we have some specialized equipment like the nanodrop spectrophotometer, which we use to quantify and determine the purity of nucleic acids and proteins. Then we also have a gradient thermocycler. Most places where you would visit will have a normal thermocycler. We have a gradient thermocycler. We have a gel documentation system, 21st century specification. Then we also have a mutation detection system for detecting polymorphisms in DNA. So apart from that, we also have a blotting facility for detection of specific proteins when you do SDS page. And then we also have a fluorescence microscope. We use in fluorescence microscopy. Those are some of the equipments that we have that stands us out. So one of the things that this laboratory does for the institute in the biotechnology department is molecular identification of organisms that we use to work in the department. In addition to that, we produce enzymes, and we need to determine their characteristics in terms of their molecular weight. So we use another technique that I mentioned earlier, is the SPH, to determine the molecular weight of the enzymes we produce. That is locally. Then within the institute, we also help with identification of different organisms, solving problems internally and externally. And one interesting thing is, we want this facility not only to address the problems of Fiiro, to address research problems outside. The lab is open to people to come for their research work, to collaborate with the institute.
Technology Department of the Federal Institute of Industrial Research, Oshodi, conducts research activities on agricultural produce right from the farm gate until the produce gets to the table of the ultimate consumer, either in form of intermediate products or in form of finished products in the most nutritious and safest forms. A lot of agricultural produce go into waste, especially during the peak season of harvest. For instance, it has been recorded that fruits and vegetable crops during peak season of harvest, at least 50% of fruits and vegetable produce go into waste. With a department of this nature, the department can concentrate or have been concentrating on developing technologies that will make use of the raw materials as soon as they are produced and convert them into intermediate and finished products.
Here is Food Product Development Laboratory. Here belongs to Food Technology Department. In this laboratory, we develop an array of different food products. Here we are able to work on roots and tubers, talk of cassava, yam, cocoyam, talk of potato, talk of sweet potato, Irish potato, and the newly invented, that's the orange flex sweet potato. We work on this. We also work on fruits and vegetables, the likes of carrots, vegetables like ugu, moringa. We also work on fruits and vegetables like pineapple, orange, name it, watermelon. We also work on cereals and legumes in the likes of maize, we talk of bambara, soybean, groundnut. All these are raw materials that we work on. Once the agricultural farm producers produce these items, our homework starts in storage, in processing, and also to develop products from these raw materials to the extent of having our consumers being able to consume such. With the wisdom of the current DG, Professor Gloria Helemo, she newly refurbished this laboratory so that we can be able to do as much as we can in getting our technologies to the end users. So this is a newly refurbished laboratory for product development activities in the Fiiro. Here you are welcome to the food processing area of the product development laboratory. Here we will take you through one of our simple technologies that cottage industries can adopt. Here we want to process yam chips. You can see very essentially the tuber should be washed before you start to peel. This is because of the microflora that comes with the yam while it is harvested. So essentially you have seen that it has been rinsed, then it will be peeled. After peeling, then it will be chipped. You agree with me that using hand to peel or using knife to peel or even to cut into shapes, you will arrive at different shapes which may not be very interesting to the consumers. It will not attract the consumers after it has been produced. Now we have finished peeling the yam. It will now be taken to the chipping equipment, and then you will see how it works. It's a simple technology that has been developed here in Federal Institute of Industrial Research. Just as I said, you can see that the yam has been cut into chips of regular shape. This is an exportable product. At this stage, it can be blanched and then packaged and put in a deep freezer. At this cold storage, it can be kept for over 6 months without change of color, without change of quality. It can be kept there until when it is needed. So processing continues. After the yam has been chipped, then it can be fried for immediate consumption. But before frying, you need to take charge of the enzymatic reaction that goes on after yam has been peeled and cut into this kind of shape. So there's going to be blanching of these chips. After this blanching operation, it will be drained and then we go to frying. Now frying can be done using a deep fryer or an ordinary frying pan. Here we are going to use this particular equipment.
I want to welcome you to Food Sensory Evaluation Lab. In product development, sensory evaluation is an integral part because whatever you develop, if it is not acceptable to human beings, then you are not develop anything, no matter the other testings that you carry out. Here, we look at the organoleptic properties of food in terms of color, taste, odor, texture, and overall acceptability by consumers, apart from the other chemical or microbiological testing. We have so many facilities. As you enter, you see the reception area where you can make inquiries about what we do here. Now, when we want to do evaluation, consistency evaluation, we usually have people that we recruit. We call them judges. Now, there's a section there that is like a mini conference room where we brief them on what we want them to do in terms of the product we are analyzing for that day, in terms of parameters that we are looking for, and other things that we want them to do. So we have the mini conference room where we brief our clients or our judges. We have 10 sensory booths. We have 5 this side and 5 this side, making 10. This is where we have our judges seated. We pass the food through this opening. We pass the tray through this opening. Now, inside the booth, we have a judge seated we have a form that is referred to as the scorecard. That is where they record their preferences in terms of how they like the product, either the color, the taste, the odor, the aroma, or the texture, or other factors that we ask them to evaluate. Now, after we have collected the results from the judges, either 10, 20, or 30, we take it to another session where we have our facilities. That's a mini computer room where we input the scores inside the computer and we analyze to look at the significant differences and compare the result of all the judges against one another.
This fish meal analog or alternative sauce is produced here, and we refer to it as Fiiro mag meal. They are mixed together with other plant protein sources, and with this we are able to get as much as 41% crude protein for the fish. You can see it eating inside there. That's it. And also we have them here too. You see them. See them. They come up to eat. So we have been able to use these feed ingredients, and we have concluded that it's very safe for fish. Not only that, it's able to support the growth and development, and above all, there is no contamination. There is no toxic residue inherent in the developed fish meal analog products. We have done the feeding trials for the fish. We have looked at the blood, the methodological characteristics. We have checked the serum. We have been able to establish that this feed product is able to support the growth of fish. We can also use in other livestock products, rabbits, poultry, that is broilers, cockerels. We can even use it on turkeys, and we are sure of it supporting normal growth and development of the different species of animals.
Manage actually 4 divisions: the technology transfer division, the planning, research and statistics division, the library, documentation, information management division, information communication technology division as well. Planning, research and statistics division, the division that is responsible for planning the research activities of the institute in terms of the facilities required for research, the funding for research, budgeting for research. Another important division, that technology transfer division, is very important because the overall objective of the DG of the institute is, after carrying out R&D activities, developing R&D projects, managing this, operating to pilot plant, we want to commercialize. So it is the technology transfer division that is the interface between the institute and the organized private sector. So the ICT division is so important in that is our outlet. That is where they are the ones that support research in terms of the technical information technology
support. Then to project the Fiiro's image in a nutshell, in a one-stop shop, we about just a few years back the DG was magnanimous enough to give us what we call a Fiiro exhibition dome. So the dome is a one-stop shop where we display all the R&D technologies of the institute, activities of the institute, and even the machinery and equipment that we have. So the dome is, we can say, is our own laboratory, where when you come in there, you see, in fact, we have a lot of display units, electronic display units in place there. Some of them we also use for our outdoor exhibition. In addition to that, what we really use as our own tool is the training pavilion, technology transfer training pavilions, that you can refer to as our own laboratory.
The mission and the vision of the department will describe what we do. The vision is to be able to connect the institute to all its stakeholders, nationally and internationally. Then the mission is to develop and implement robust strategies that will enable us to achieve the vision. That is connecting all the institute's stakeholders with Fiiro services and activities. The department is the gateway to the institute, linking the institute with the outside world. To be able to achieve the vision of the department is organized into 3 major divisions. The division that coordinates the activities or connects Fiiro's activities and services to the industry stakeholders is called the division we call Industrial Linkage Division. So every activities of institute as it relates to industry is being coordinated by this division. So then we have another division that we call Partnership and Zonal Offices Coordination Division. See, just as I said, that broadly we could classify our stakeholders into industry stakeholders and non-industry stakeholders. So the P&Z department concentrates mainly on the non-industry stakeholders. Then the third division in the E&L department is what we call TET, that is Techno Entrepreneurship and Techno Economics Division. See, the first 2 divisions, they link directly. They link the institute directly with the stakeholders. But for them to be able to do that effectively, they need data. They need information. So this TET, one of the aspects, one of the key function, the core assignment, the core competency that we have in TET is the economic evaluation of all our R&D projects.
When we want to look at the financing of Fiiro, we need to get it right from the perspective of an outsider for information. It is wholly owned by Federal Government of Nigeria under the Federal Ministry of Science and Technology, and we are majorly funded by Federal Government of Nigeria.
through the annual budget, the personnel, the recurrent expenditure, and the capital expenditure are funded by federal government. Even though we do have little additional funding once in a while from World Bank and other agencies, but 97% of our funding from federal government. And we usually manage whatever we have judiciously.
The most important thing for us is leadership. If you show, managing people is quite complicated and quite complex somehow, but if you are really sincere and if you show that you have focus on what you are doing, and that if people know you by the philosophies that you stand for and by what you know you are capable of doing, I think people will always follow you. The problem we have is, people say some different things and they do other things. But if people know you, that you stand by what you say and that you act by what you say, people will follow you. Of course, we know that it's not easy to manage people. But what we know is that if people also follow people who have integrity and who can command, it's not just about leadership. If you have leadership potential, if you don't compromise, people know you that you stand on certain principles and that what you do for A, you do that for B. And that what you do for Mr. Lagbaja is what you do for the other person without compromising. If you keep the rules, as it is, without compromising on anything, people will know where you are standing in any situation and they will be willing to follow you. So it's not a problem for us to manage the people we have here. The only thing that we try to do as much as possible is to make sure that we go under the rules of engagement. We are guided by the rules of the public service and that we don't compromise. So whatever way, if we do it, satisfy your conscience that you have done the right thing, then the law will take its course. That's the only way we think we can get it right.
The procurement department is all about procurement of goods, works, and services in line with the Public Procurement Act 2007 for Federal Institute of Industrial Research, Oshodi. Procurement activities involves being efficient. So we want to improve the process, make it more efficient. We want to make the process to be more, to have value for money. We want to make the process to be accountability. We want to be able to account for every kobo that we spend in acquiring goods and services. I want to make sure that within the period, every department, other departments in Fiiro, they are able to acquire just what they need to make them functional, not just buying junks or buying equipment that will not serve them. So, and I want everybody in the system to be able to have confidence in us that we are able to do this. We will do this by relating to them one-on-one to make sure that we are their friends, we are not working against their interests and the interests of the institute at large and Nigeria.